All right, so 1/6. Okay, there's going to be two sections to this. Talking about absolute value. You guys know what absolute value is? Okay, so absolute value is going to be the symbol that we use, okay, is these two vertical bars. And then we're going to put some algebraic expression that goes inside here. Okay? But by definition, all absolute value means is that it's the distance. And I put quotations here, something, so it's going to be an algebraic expression or whatever. It's the distance something is away from 0. Okay? Says this something can be either on either side of 0, and that's why we're going to have two answers here when we're done. Think about this. If I say the distance away from 0, let's say I put 0 right here. Okay? And I ask you to walk, let's say, C units over here. Okay, so that would be C. Does that make sense? A distance of C. So it could, let's say C is like 5. Walk 5 units to the right of 0. Would you then, standing at C, be 5 units away from 0? Yeah. Could you do the same thing but walk this direction? And say, okay, well, C, the coordinate for C would be -5, but did you still walk 5 units that way? Okay. Because of that ability to start, if we're talking about distance from 0, and I can walk either to the right of 0 or I can walk to the left of 0, that is the logic of why we're going to have two answers. Okay. Now, distance is always what kind of number? It's always positive. Okay. It can be 0. Okay, that's kind of boring though, but it's always positive. You never get into Google Maps and type in a location that you want to go to and it come back with, well, it's negative 52 miles. Okay, never happens. It's always distance traveled. It always has to be a positive number. So that being said, we're going to have a rule here that allows us to find the distance to the right of 0 and the distance to the left of 0. And our solutions might be positive and they might be negative, but when I plug back in, they satisfy my original equation. The absolute value symbols, okay, it's like an operation, okay, so these bars are a grouping symbol, okay, so they're kind of like parentheses, but they're a little bit more than that. They always make what number is inside them positive. Does that make sense? So if I go to, just kind of demonstrate this with Desmos real quick. If I have the absolute value of A, so absolute value on your keyboard, if you're going to use Desmos, which I strongly suggest with some of this stuff, absolute value is the, you got your enter key, and then right above it, you've got a key that has a vertical line and then a backshift or a backslash. That's your absolute value key. You got to hit shift and then that key, and it'll give you absolute value. Or you can just type in ABS in parenthesis A, and it does the same thing. Okay. But look what happens. So when I do this with A, it creates a slider that I can just choose any number I want to. So if A is 3.9, put it inside those absolute value bars, so this would be a 3.9 in here, you get back 3.9, right? So if it's positive, it keeps it positive. Okay? When it's 0, it keeps it 0. And we'll talk about 0 several different ways. This year, we'll talk about 0 being, depending on how we are interested in it, what we want to do with it, we might say, well, 0 is a non-negative number. I'm not going to say it's positive. I'm just going to say it's not negative. Does that make sense? Or I can say 0 is a non-positive number. I'm not going to say it's positive. I'm just going to say it's not negative. Does that kind of make sense? Okay. But I could take the absolute value of 0, which is 0. But now if I go put negative numbers in, you see how if I put a negative number in here, it still turns it into a positive, right? So absolute value is always going to take something and make it positive. Okay. I've got, this is the definition that our textbook gives, okay? I'm going to change it a little bit to make it, I think, what might seem a little bit simpler for us to use. Let's come to the side here and write this. What we're going to look for, and this is what these red rules here in a moment that we'll go through, explain step by step. But I have a statement that says if I have the absolute value of our expression, if that is, I'll actually write the whole word out here, expression. If that is equal to C, then you're going to have two equations that you can build from that. And the one equation is the idea that we are going to walk a distance to the right of 0. So we would have expression equal to C. And the other one, so I'm going to write or, and this would be the idea of being able to walk to the left of C, or sorry, left of 0 to negative C. So I have my expression equal to negative C. Okay. Now, when I say expression, that's like an algebraic phrase. It might be x, it might be 2x, it might be 2x plus 5. Okay. But that's an if-then statement. Okay. So in geometry, you guys should have learned geometry integrate 2. Like if I had a phrase like this, let's say if it is Saturday, then college football is on all day long. Okay, let's say I have that. Let's say that's a true statement, which is roughly true, right? Okay, and then I have this next statement that says today is Saturday. Okay, with those two statements together, you should be able to make a conclusion about the today that I just gave you. Because that statement right there doesn't match that statement right there. Doesn't match the if part. 2 days being Saturday. They match, right? So what could you tell me about this day? You could tell me, you can make that conclusion. Does that make sense, everyone? Okay. Now, if I said this, if I said today was Wednesday, does that match that? Does Wednesday match it being Saturday? No. So because there's no match there, you can't say anything about college football being on all day long. It might be, but it might not be. We don't know because the 2 days don't match, right? Okay. No, I just can't. I can't make a conclusion. It's the idea. Let's say that, let's say I'm a student and you say Mr. Fay is not an A student. Does that automatically mean that I'm the complete opposite? That I'm an F student? But I could be a B student, a C student, or a D student, right? Or an F student. Okay. So just because it's basically because they don't match, you can't make a conclusion one way or another. Okay, and that's the one thing that we want to do in mathematics all the time. It's inherent. Human nature says if it's not this, then it's got to be the opposite. If the water is cold, or sorry, if the water is not cold, then it automatically we have to think it's hot, right? But it could be lukewarm, could be room temperature, that kind of thing, right? Could be boiling. Okay, but I don't know, so there's vagueness there, so we don't make a conclusion. Does that make sense? The reason I make this comparison is because when we have a specific problem that we're going to go through, okay, like this question here, that does not match our statement that we just made, our if-then statement. So we can't do anything with that yet, okay? And this is what the red steps here could all be cut out if we understand this concept here of having to match the if part, okay? Our specific question has to match the if part. And that's how we apply all rules in mathematics. Whether you've been learning math since probably what? First grade? Okay, maybe even before then. Every rule that you've ever been taught and every procedure you've ever been taught is presented as an if-then statement, okay? And you can only do what you want to do with that rule that you want to apply if what is in front of you matches the if part of some rule, okay? So we'll spend a little bit more time on that here in a moment when we do a specific question. But here are the steps. If that does not make sense to you, here are more direct step-by-step procedures, okay? Step 1 says do everything necessary algebraically to isolate the absolute value symbols. And that's essentially what our rule tells us to do. You have to get your absolute value symbols all by themselves on either the left-hand side or the right-hand side, okay? So if I look down there that says solve the following absolute value equation, you see where it says absolute value of x plus 2 equals 9? That plus 2 is on the same side as the absolute value, so the absolute value is not isolated yet. We have to do all the necessary algebra to get that all by itself, okay? Step 2 says get rid of the absolute value bars and solve the remaining equation. It says this is allowing you to find the distance to the right of 0, okay? But that's only one answer. So the way we get our second answer is we go back to the equation you have in step 2, you rewrite it, but then you make one side negative. Okay, it doesn't matter. I usually try to find the smallest side in terms of the amount of terms that are on it, and I make it negative. And what that does is now allows you to find the answer that is on the opposite side of 0, to the left of 0. Okay. When we're done with those, we have our we solve that equation. We have our two solutions. We graph them, and then we write our solutions as they set if they're calling for that. So let's do this question right here real quick. So my question first, we'll approach it this way, because I think if we understand how rules like this are applied, then it will make our understanding of just math in general so much easier. So right now, here's my specific question, right? Does that match what is being shown inside my blue rule? Do I have an expression all by itself in absolute value bars on the left-hand side equal to a number on the right-hand side? I don't have that yet, right? So far, this would be the idea, like, instead of it being Saturday, it's like Wednesday. I can't make a conclusion. I can't get this information yet. Okay? I can't get that blue stuff or write that blue stuff until my particular problem looks like this yellow. So my particular problem then, I need to get the absolute value by itself. So can I subtract 2 from both sides? Okay. Now do you see how this is an expression inside the absolute value all by itself, right? Equal to some C, some constant, some other number. Okay. So now those yellow things match. So now if the yellow things match, we can then say this blue thing about our specific problem. So it was whatever the expression was, which is x, is equal to 7. Okay. Or your expression, which again was x, is equal to the opposite of our c, which is the opposite of 7. Okay. Does that make sense? And now what that really means to us, those two numbers, think about this. I'm going to look at the one, instead of looking at this top one, it's a little bit easier to think about this bottom one here, this yellow one. If I plug in 7 right there, does the absolute value of 7 equal 7? Absolute value of a number is going to make it positive, right? Put 7 in there, make it positive, it's 7. Does that equal 7? Yes, it does. So that's a solution. Put negative 7 in here as x. Absolute value takes a negative number, makes it positive. So is negative 7's absolute value turn into 7? Yes, it does, right? Does those two numbers, if we were to graph those two numbers, on a number line. So if I have 0 right there, put 7 down here, put -7 there. When we graph just points, just one solution, all we do is just graph the dot. Okay? But would you agree that those two solutions place that expression 7 units away from 0? Either 7 units to the right of 0 or 7 units to the left of 0, right? That kind of makes sense? Okay. When we write our solutions, you can see this a couple different ways. This is okay. This is fine. Okay. But when we have multiple answers, a lot of times, they will make these curly braces, which I know it takes some practice to get good at drawing those. But they'll just put the two solutions in here, separated by commas, and then close those curly braces. In Math Excel, usually the curly braces are already there for you, or they just ask you to type in your answers separated by a comma. The reason I talk about that is you will go through other classes. I will give you things this year that introduce that notation or use that notation, and I want you to have some experience before or seeing it before we actually get to those situations. Okay? I think one of the hardest things in any math course is not the algebra, not the thought and all that kind of stuff. It's taking the notation that they use, the shorthand symbols and all that kind of stuff, and having an understanding of what they mean. Anybody in Spanish? Spanish, you've got like accent marks on top of letters and tildes and upside down question marks and all that kind of stuff, right? If I don't know what those things mean and they're not taught to me, is it going to be hard for me to read and comprehend that Spanish? Yeah, okay. Even in English, if I don't know what a question mark in English means, that statement is completely different than somebody poses a question in words to me on paper, and I don't know what a question mark means. I interpret that as a reader different. If I don't know what an exclamation point means, I interpret that differently as a reader, right? Okay. So there's notation that's important in math that if I don't know, I might interpret things differently. Okay. Let's go down to this next example. Are my absolute value bars by themselves here? Are those isolated? Nope. So what do you got to do? Add 5. So that's going to give me the absolute value of n is equal to 3, right? So if absolute value of n is equal to 3, now that matches what our rule was. So now once I have the absolute value isolated, I can say n equals 3 or n equals the opposite of this number, so the opposite of 3. So at that stage right there, that matches if the absolute value of an expression equals c, then we can take the expression equals c or the expression equals the opposite of c. And these two, and we've seen it in both the last two examples, but those answers pop up right away. Okay? There are going to be examples, like this next one, that the answer doesn't pop up right away. Okay? Actually, let's skip that one because the next one is actually a little bit simpler. Let's go down to that bottom one. The 2D1 plus 4 equals 8. Okay? And then we'll come back up to the other ones. So if I look at that one, okay, are the absolute value bars by themselves? No. Okay? Now, the absolute value bars, they're a little bit more, there's more operation to them than parentheses, okay? But they're still grouping symbols. Does that make sense? They still get us to focus on the D plus 4 being like one thing. So that 2 out front, if there's no symbol between the 2 in the absolute value bars, this means 2 times the absolute value. Does that make sense? So how do I undo that multiplication? How do I get rid of this 2? I'm going to divide. Okay? The one thing you don't want to do with absolute value is distribute into it. Okay? That can be messy. So I'm going to divide both sides by 2, and I get d plus 4 in the absolute value equals 4. Okay? Now, if we go back to if you have an expression equals c. Is that what we've got right now? An expression inside the absolute value equaling c? Where c is our 4 now? Does that make sense? Then you get 2 equations. You get the expression equal to c. So I'm going to start with d plus 4 is equal to 4. Or you get the expression equal to negative c. So I'm going to write the word or. I'm going to write my expression, d plus 4. And now I'm going to take whatever this number was and I negate it. I make it negative 4. And one thing that we have to pay attention to, especially in mathematics, when we see the word or, it's not giving you options. Like you don't have, you as a student will say, oh, I could do one of those or the other one. You have to still solve both of them. Does that make sense? But every year I talk about this. So it's kind of interesting because this is actually going on right now in my college algebra class. We're doing the same stuff. Doing the same stuff in this class, and integrated 1 is actually talk about this stuff. They'll talk about it in like chapter 7 though. But every year I teach this, I will get a handful of students to think that when they see the word or, that they only got to solve one of those, and they get half the answer, but it's not an option. Okay, so you have to do this one here. So how do I solve for d here? Subtract 4. So d ends up being 0. I'll come over here and subtract 4 again. And d equals negative 8. Okay? And what that does, think about what these two solutions do. Okay? If I plug them back into the original problem, okay? Plug 0 back into the original problem. What's 0 plus 4? 4. What's the absolute value of 4? 4, again, right? Times 2 then is 8. So it works, right? If I plug negative 8 in, okay? What's negative 8 plus 4? Negative 4. What's the absolute value of negative 4? 4 times 2 again. Does it come back and give me 8? And those are the only 2 numbers out of the entire number system that will do that. Is that okay with everybody? All right, so this is a little bit different than the last one, because the last one we knew right away that the expression was just the variable. So when we wrote our or statement, essentially, we had our 2 answers instantaneously. Here we got to do a little bit more work to end up solving for those variables. Let's go down one more. Let's do this one because that's kind of on the same level. Okay, so what are you going to do here to isolate? Say it again. Careful. How is, I agree that you're going to do something with this negative 4, but how is it attached to this thing here? Think about this. So this thing here is just an object, right? So I have 3 equals an object or an expression, and then that. What is, it is a negative 4 if I just looked at it by itself, but when it's object, and then, isn't that saying minus 4? Does that make sense? Okay. So if that's minus 4, then you're going to add 4, right? Add 4 there, add 4 there. So it gives me 7 is equal to the absolute value of m plus 2. You don't have to do this, but I like to flip these. I like to see my absolute value come first. Totally up to you. But now that matches my rule, right? I've isolated my absolute value. So now I say m plus 2. M plus 2 should equal what? 7. Or m plus 2 equals negative 7. And then you can subtract 2 from both sides. You get 5. And there you get negative 9. Is that all right? Using that logic, or what we've seen there, now I know this is a little bit harder of a question. Go through this top one that says 3 times the absolute value of 2z plus 9 plus 12 equals 21. See what you come up with, okay? Talk with people around you, ask each other questions, help each other, and then we'll reconvene and talk about that. What's the first thing you guys did? Okay, so if you divide both sides by 3, how does that look when you're done? Okay. So that's perfectly fine, okay? My thought is I would be cautious of that. Did anybody do this? Okay. I think that's the same. And what you did, Jenna, is perfectly fine because you remembered that you had to divide the 12 by that, okay? A lot of people will divide, if division is the first thing they do, they will not divide that 12 by it, and they'll just bring the 12 straight down, and it creates issues. Either route's fine, okay? And why is either route fine? Let's go with this route. What would you do next here then in this side? You subtract 4, so you got absolute value of 2z plus 9 equals 3. Those of you that went this route, what did you do next? Divide by 3. Still give you absolute value of 2z plus 9 equals 3. So that kind of tells us because at some situation, some juncture in either side, either problem, we end up with the same exact statement. Tells us that both routes that were taken were acceptable. So now at this state, this is our rule, right? We now say 2z plus 9 equals what? 3. Or 2z plus 9 equals what? Negative 3. Good. And then we solve those individually. So subtract 9. We get 2z is equal to negative 6. Did you guys get z to be negative 3 for one answer? Okay. Here's one thing that I think's something that's going to help you. Once you get down here to this or statement, the math that you do right here, it's identical over here. So you subtracted 9 here. You're going to do the same thing here, right? Now you get different results, but 2z minus 12. Then you divide both sides by 2, right? So still divide both sides by 2. Did you guys get the other answer to be negative 6? Fabulous. Okay. So those are our answers. Now, here's a question that they always ask. They always ask this. It's a special case. Okay, and I will only talk about one special case today. I don't have the other ones up here. What would you do first here? Add 5, good. So I got absolute value of 3x minus 6. Add 5 to here. Add 5 to there. It gives me negative 2, right? Okay. Now here's where you'll hear me talk about being a calculator. Okay. Because you got the rules. And you know the rules. And you can apply the rules. And a lot of people will say 3x minus 6 equals negative 2. And then they'll say 3x minus 6 equals positive 2. because they get in that pattern, that habit of just doing a procedure over and over again, right? But when they do that, when you become a calculator, you forget to think, because calculators don't think, right? All right? Think about this. What do those symbols mean? What do those bars mean? Absolute value. So I'm talking in a discussion with you, and I say the word absolute value. There's a definition of absolute value, right? Okay, so I can replace that word absolute value with the actual lengthy definition that says the distance that something is from zero, right? So the way I can read this red statement as the absolute value of 3x minus 6 equals -2. Or I can read it as the distance that 3x minus 6 is away from 0 is -2. And think about what I said. I said the distance something was is -2. What's wrong with that? Good. I can't have a negative distance. So that is algebraically what we get. Okay, the design of this problem sets that up. We haven't done anything wrong yet, but we cannot solve this. There is no solution to this because distance cannot be negative. So no solution. Okay. Do you guys know what your lines look like or your graphs look like for absolute value? Have you ever seen those before in other classes? If I have 3x minus 6 as a line, so here's 3x minus 6. That's my line. The absolute value takes every y value that was negative on this purple line. So all these y values from my cursor right now this way, and it makes them positive. So if I put that in there, that's what the absolute value graph looks like for a line. Okay? Now, if I put -2 in here as my other equation, my other side of my equation, you guys remember talking about this the other day? When I'm trying to solve an equation, it's where the left-hand side graph intersects the right-hand side graph. Do the two sides intersect here? Does the purple intersect the red? No. So there's no solution to that. Okay? I think it's important not only just to be able to do the math, be able to do the calculations, but to understand that this is really what's going on in the background. And because they don't cross, these two lines and curves don't cross, we don't have any solutions. Okay?